Australia's public affairs channel.
Okay, thanks for coming along this morning. My name is Will Steffen. I'm a climate counsellor with the newly formed and publicly funded Climate Council of Australia. And we're releasing a report today on the hottest year on record for Australia, 2013. But the purpose of our report is to put this in a larger context. In other words, to put the remarkable year we've just had in Australia into a global context and into a long-term context. And when you do these two things, you can see the connection between the weather we've had during the past year and climate change. And again, there are several points to this connection between 2013 and the fact that we have a long-term warming and destabilization of the climate system. First, the physics. We are accumulating more heat, more energy in the atmosphere year by year by year as greenhouse gas emissions continue to go up. That stacks the odds for warm weather, for hot weather, for extreme weather, and for record weather. So 2013 is a manifestation of the fact that we've got more heat in the atmosphere, in the climate system. Second of all, long-term observations. We've seen in Australia over the past 50 years that the number of record hot weather records that have been set, monthly records, daily records, and so on, has increased by a factor of 2. It's more than doubled since the 1950s, whereas the number of cold records set has correspondingly dropped. This does not happen with natural variability alone. This happens when you get an underlying trend in the climate system. So the fact that the temperature is going up on a long-term basis, it wiggles, oscillates from year to year, but the fact that it's going up statistically says you have now increased odds of getting record hot weather like 2013. And the third thing, we can actually test this with sophisticated climate models that simulate patterns of natural variability. A lot of people will say, well, the climate goes up and down naturally. This is just another feature of that. When you actually test that in the models, you can do thousands of runs of these models, and you see that the odds of a record year like 2013 happening with only natural variability are vanishingly small. You put all this weight of evidence together and the fact that heat waves and hot records are happening elsewhere in the world, and you get a very, very clear and compelling picture. In fact, I think the evidence is now irrefutable that these extreme weather events, these extreme years, are in fact being influenced by climate change. Climate change is increasing the odds that they're going to happen. So what we try to do is look at that remarkable year, and it was a remarkable year. We had the hottest summer on record. We had the hottest spring on record. We had the hottest January, the warmest September. We had the hottest summer day and the hottest winter day. And that heat around Australia was actually spread around the entire continent. When you look at all the states in the Northern Territory, the average temperature there experienced in 2013 ranked in the top 4 years for each of those states. And that's very unusual to see heat spread that widely around the continent and that consistently through the year. Again, the fact that we have more heat in the atmosphere due to greenhouse gases is stacking the odds toward that sort of weather occurring. The final point we make in this short report is that we do indeed have a climate that is increasingly being destabilized. Heat waves, hot days, hot years like 2013 are one example of that. But other aspects of destabilization are occurring, like periods of exceptionally cold and stormy weather, like the northern hemisphere is experiencing during their winter. The point we make is if we want to return to a stable climate that we've had for centuries before the 20th century and before particularly the second half of the 20th century, there is only one way we're going to stabilize the climate, and that's to reduce greenhouse gas emissions, do them very rapidly, do them in an ongoing basis through the coming decades, and basically decarbonize economies. The science is absolutely clear on that point. So again, 2013, put in a larger context, is a symptom of a destabilized climate, and again just highlights the challenge we have here in Australia and around the world to get our emissions down if we are going to stabilize the climate again. So let me stop there, and I'm happy to discuss any of these points further, take questions and so on.
Do you have a view about these scenes we're seeing from the North America at the moment with incredibly cold conditions, and whether it's possible at this point to say whether it's linked to climate change, or whether it's too difficult to know?
Very good question. Let me walk you through that. The link between this very intense, cold, very stormy, very snowy weather that they're experiencing in North America and climate change is probably there. The evidence isn't as strong as there is for the excessive heat events. But let me walk you through what's happening. Basically, it's the result of what we call a wandering jet stream, or nowadays it's often called a drunken jet stream. Jet stream is a circumglobal wind track in the mid-latitudes. And its pattern is normally very well constrained, and it's well constrained by the following fact. You have a temperature differential by the equator, which is hot, and the North Pole, which is cold. And the sharper that gradient is, the more constrained that jet stream is as it circles around the world. And that's the pattern that Europe and North America, Siberia, has gotten used to. What's happened over the last 30 or 40 years is that differential is changing. The equator is warming, but not nearly so fast as the Arctic is warming in the high latitudes. They're warming at a higher rate. So in fact, the gradient is becoming shallower. And what that does is it does not constrain the jet stream so strongly. So the jet stream, as it goes around, is now wandering up and down as it goes around the planet. Now let me just give you a very, very interesting fact. You can look at North America and look at what's happening there, but you should go to the World Meteorological website. Look at Siberia in November as this jet stream started to wander. Absolute record, unbelievable heat throughout most of Siberia, all the way up to the Arctic coast. They were having temperatures 8 or 9 degrees Celsius above normal at the Arctic coast. So that's an example of a wandering jet stream. It brings cold air down in one place and brings incredibly warm air up in another place. We've been seeing this happening. We've seen it in Western Europe. We've seen periods in North America where the winters have been exceptionally mild because the jet stream was wandering in the opposite direction. So this notion of a wandering jet stream is something we've only begun to see in the last couple decades. And the evidence is getting stronger from the observations and indeed from the modeling studies that it's this decreasing gradient of heat from the equator to the Arctic Ocean, which is sort of releasing the jet stream to wander northwards and southwards as it goes around the globe. I'm sorry that's a bit of a long-winded explanation, but yes, there is probably a link between a destabilized climate system because of excess greenhouse gases and the behavior of the jet stream.
In light of what you continue to say about the need for action, how sceptical are you of the prospect of a proper global deal involving the major emitters?
Okay, as I said before, we need global action, deep emissions, rapid emission cuts, and so on. There's been a lot of discussion about the UNFCCC, the Climate Change Convention negotiations. Well, that's only one tool in a whole toolkit that the world has to deal with this problem. What we're seeing, particularly since Copenhagen in 2009 and basically the breakdown of that process, is a lot of other action outside of the UN process. We're seeing it in small groups of countries like the Scandinavian countries working together. We're seeing it within countries like states within the United States and cities within the United States. We're seeing it at the country level. And if you look around the world now, I think at last count, I have to check my numbers, but I think it's 30 or 40 countries now have pricing systems on carbon of one type or another on carbon emissions. You're seeing countries like South Korea with a real push for high-tech solutions, green growth, and so on. And you're looking at a thing like the Green Growth Institute in South Korea, which is a partnership between a number of Asian countries and Australia. So you're seeing all sorts of ways that countries are trying to get emissions down. And if you look at the net outcome of that, you can start to see the first hints that we are starting to change emission patterns. 2013, 2012, we started to see a slight slowing. Emissions are still going up, but not quite at the high rate they were the decade before. The United States, they've seen a 7% reduction in emissions over the past decade. A lot of that's due to fuel switching away from coal and to gas. China is moving fast now in terms of getting the emission intensity of its economy down. One of the most rapid drops in that we've seen anywhere in the world in history. So countries are indeed taking it seriously. And I think what we're going through is a period of confidence building. And when countries see they can come to an international table, make a commitment and deliver on it, have the confidence they can do that, we'll actually see more action at the international level. So I think it's a process that we're going through that involves a number of institutions in addition to the UN.
Do you have a view about this, the Russian ship that was trapped in Antarctica by the sea ice?
Yeah.
I read a few pieces. One was in the New York Times, one was in National Geographic about whether that rescue and that expedition actually took resources away from some other science that needed to be done in the Antarctic?
Yeah, look, my understanding of that was that cruise was not an official cruise. It was a private cruise that it did involve some scientists. And my understanding is, yes, it did take some resources away from official scientific cruises who are well prepared for all different types of sea ice, who had to divert some of their resource to give assistance to the ship that was in trouble. So in that regard, it's regrettable that these things happen, because it does take time and resource away from the official legitimate science that goes on down there. And it's exceptionally important science. I should add that I'm also chair of the Antarctic Science Advisory Committee here in Australia. And Australia plays an important role. We've got a number of stations, 3 stations in East Antarctica. We have a ship, the Aurora Australis icebreaker, that goes down and services these stations. And when we have to undertake rescues, as other countries have to, the United States from time to time, it does indeed divert valuable and scarce resources away.
Do you think then that it might be time to reconsider the sheer number of visits to Antarctica, you know, whether it's tourism or whether it's private expeditions, given that, you know, there's the huge cost of rescuing people?
Yeah, look, I'd need to look at the statistics before I could make a real informed statement on that in terms of how often this happens, how much resource is being diverted away by either tourist ships or informal private expeditions that tend to do a bit of scientific work and so on. One would have to look at the statistics and see whether that's now becoming a big problem, and if so, whether it needs to be dealt with. I would say that the governance for Antarctica is actually very good. It's an example of an international system that works very effectively. And if it is becoming a big problem, I'm sure that the Antarctic nations, the Antarctic Treaty nations, will get together and come up with a good solution. They've got a pretty good track record of dealing with issues as they arise in managing Antarctica.
Professor, a slight tangent, but the Abbott government's looking at reviewing health impacts of wind turbines, wind farms. Do you have a view on that, or is it not?
I will just foreshadow that we've been talking about in the Climate Council of doing a report on health impacts of energy systems in general. And that's not just wind, but solar and conventional energy systems, coal, oil, and gas, because all of those have health impacts too. They have health impacts from the mining, they have health impacts from the use and burning of those fuels. And to be honest and fair, you have to make a comparison across all major energy sources before you can make any judgment on that. I will also comment that there's been a lot of work done on that in countries like Europe. I'm reasonably familiar with Denmark, and Denmark has handled the situation by, I think, having a 1 kilometer buffer between residences and places of work and where wind generators are. They've had the longest history of any country that I know of with modern wind generators, and I don't think they've seen any health problems with the precautions and buffer zones that they've instituted.
So long as there's a distance, a buffer zone.
Yeah, and I think, if I'm not mistaken, you can double check me on this, see if I got my facts right. I think it's the buffer zone in Denmark is 1 kilometer between the wind generator and a residence, and they've had wind generators for decades now, and I don't think they've seen any health problems with that.
There's time to time claims about the sort of noise impacts and people's health being hurt. Do you think they're overstated?
I think we'll have to see how our report comes out. I'd like to discuss that when I get the facts to hand. And tell you exactly what studies have been done around the world on the issue of health and wind generators. Because I think there's a lot we can learn. It isn't the first time this issue's been raised. The Scandinavian countries have looked at it for a long time, and they have a long history with it. And I think we should learn from that.
Do you have a time frame for that plan?
Yeah, look, it's going to come out the first half of this year if we go to plan. We're having a meeting in Sydney at our new offices in the next week or two, where we're going to sketch out what we're going to do. I should also foreshadow that we are working now on a report on heat waves. That hopefully will come out in February. That's a report much more comprehensive on the science of extreme heat, not just in Australia, but around the world, and most particularly the risks of extreme heat. We were just talking about health risks of wind generators. Well, far more severe health risks with extreme heat on our body, on our physiology, on our work productivity, on ecosystems, on infrastructure. We saw some of that in Melbourne in 2009. So I think it's really important that we talk about what are the health impacts of just allowing the climate to be increasingly destabilized. I suspect they're seeing some health impacts with the extreme cold and stormy weather in the United States as well.
Just on energy sources and health, do you have a view on fracking? Is it clear at this point on the science about any side effects from fracking?
No, fracking is a bit out of our terms of reference as a climate council. There are a lot of other groups who are studying impacts on the hydrological system, on groundwater. Those are important issues. We're not in a position as a council to take that on. The only aspect of fracking that we do take on as a climate council are the implications for greenhouse gas emissions. And they work in both directions because gas, as you know, emits less greenhouse gas than coal per unit energy produced. That's one of the reasons the United States is dropping its emissions, is it's switching to gas. On the other hand, there are fugitive emissions, that is emissions that escape during the mining process. And many of those would be methane, which is a more potent greenhouse gas than CO2. I haven't seen a good consensus yet on how serious that problem is with fracking, and I suspect it's going to be highly variable depending on the nature of the site where it's occurring. So that's the one thing we as a council would take a look at, would be what are the fugitive emissions associated with fracking, how serious are they, and I haven't seen yet a consensus in the scientific literature on the answer to that question.
Do you have a view on gas as a transitional fuel to move away from coal? Does it stack up as a source of cleaner energy in a relative sense?
It stacks up as a transitional fuel, but not a destination fuel. The best way to look at this is to look at a carbon budget approach to stabilizing the climate. Now, what that's saying is that if we want to stabilize the climate at a 2-degree temperature rise, and we're approaching 1 degree now, there's only a certain amount of carbon, CO2 basically, that you can emit. It doesn't matter whether that comes from coal or gas or oil or non-conventional fuels. It's the amount of CO2 that you emit that's limited. Now, by switching from coal to gas, you can actually extend the amount of energy you can produce for that carbon budget, but there's still a limit on it. And if you actually look at the world's known reserves of fossil fuels, that's conventional coal, conventional gas, conventional oil, plus the non-conventional ones like coal, steam, gas, and so on. What you find when you look at that budget is you can only burn a small portion of that. And it could be somewhere between 20 to 35%, depending on the assumptions you make in your calculation. However you cut it, you've got to leave more than half of those reserves in the ground if you want to stabilize the climate at that 2-degree target. So yes, you can buy time, get more energy per unit fossil fuel you emit by switching to gas, but it's not a destination fuel. The destination energy sources are the no-carbon sources. The renewable sources, obviously the solar, the wind, the geothermal, perhaps wave energy and others that come on. Those are the ones that don't emit carbon gases as they produce energy.
Thank you.
Thank you, guys.